Hello everyone, and welcome back to the Fluctus Channel.
At 2995 today.
You took 75 points.
American reconnaissance aviation began with crews carrying cameras over enemy territory, then evolved through high-altitude aircraft, electronic sensors, and airborne intelligence platforms able to monitor entire regions without firing a weapon. Today, one of the most important examples is the RC-135 Rivet Joint, a heavily modified four-engine aircraft based on the C-135 family. Its mission is to collect, analyze, and distribute electronic intelligence while airborne. Rather than photographing targets, the aircraft listens for radar emissions, communications, and other signals that reveal how military networks are operating. The information can support commanders, air crews, ships, and ground forces in near real time. Before departure, maintainers inspect the airframe, antennas, landing gear, engines, and sensor housings. The aircraft also requires regular washing because dirt, salt, oil, and residue can damage surfaces or hide developing problems. Mission specialists board through the forward entrance carrying personal equipment, classified materials, and checklists. Inside, the aircraft resembles a narrow airborne operations center. Rows of consoles line the cabin, with screens, controls, headsets, and communication equipment arranged for intelligence operators, electronic warfare specialists, and airborne linguists. Each station supports a specific part of the mission. Some operators search for signals, others measure their characteristics, and linguists listen for spoken communications in assigned languages. Analysts compare new information with known patterns to determine where a signal originated, what system produced it, and whether activity has changed. The crew must work quietly and methodically. A single transmission may last only seconds, so operators record timing, frequency, direction, and content, while other specialists verify the result. Information judged important is passed through secure channels to commanders who may be hundreds or thousands of miles away. Long missions require aerial refueling. A KC-135 stratotanker approaches from behind. The receiver holds a stable formation, while the tanker's boom operator guides the rigid refueling boom into the receptacle above the aircraft's cockpit area. Once connected, fuel moves through the boom, while both crews monitor pressure, position, and turbulence. This process allows the rivet joint to remain on station far longer than its internal fuel alone would permit. During operations over Afghanistan and other regions, aerial refueling extended surveillance missions while reducing the need to return to base. The RC-135 does not attack targets, but its information can shape what happens next. It may detect changes in radar activity, identify communications networks, or provide warning that another aircraft is approaching. That makes the aircraft part of a larger defensive system linking surveillance platforms, command centers, tankers, fighters, and ground radars.
Your endurance there will be 232-ish.
Its value lies in persistence. While fast jets may pass through an area in minutes, the rivet joint can remain nearby, collect patterns over time, and help commanders understand what an opponent is doing before deciding how to respond. Every mission depends on precision, patience, teamwork, and discretion. The information collected by reconnaissance aircraft becomes most useful when it reaches forces capable of acting on it. At sea, the E-2D, Advanced Hawkeye, provides carrier strike groups with airborne early warning, command, and control. Its most recognizable feature is the large circular radar dome mounted above the fuselage. From altitude, the radar can scan far beyond a ship's horizon and track aircraft moving across a wide area. A 5-person crew combines pilots with mission system operators who manage sensors, identify contacts, and coordinate other aircraft. Before launch from an aircraft carrier, deck crews unfold the wings, inspect the propellers, remove safety pins, and guide the Hawkeye toward a catapult. Once airborne, it climbs to a patrol altitude where its sensors can watch the surrounding airspace. Operators compare radar returns with flight plans and friendly identification data, separating routine traffic from contacts requiring attention. When an unknown aircraft approaches, the Hawkeye can direct fighters toward the correct position. Super Hornets, or other interceptors, launch from the carrier, climb rapidly, and receive headings, altitudes, and updates through secure communications. The E-2D does not need to fly directly toward the contact. It remains farther away, building the wider picture and helping fighters arrive with better awareness. The EA-18G Growler adds electronic attack to that defensive network. Based on the Super Hornet airframe, it carries receivers and jamming equipment designed to detect, analyze, and disrupt hostile radar and communications. During coordinated missions, the Growler can support strike aircraft by reducing an opponent's ability to track or target them. Marine AV-8B Harriers have also carried air-to-air missiles for defensive missions. Ground crews inspect the weapons, position loading equipment, raise each missile beneath the wing, connect it to the launcher, and complete electrical and safety checks. Together, these aircraft divide the problem. Reconnaissance platforms collect signals.
5203.
Hawkeyes track movement and manage airspace. Growlers interfere with hostile electronic systems. Fighters carry weapons and close the distance. The strength of the system comes from coordination, because no single aircraft can search, identify, jam, intercept, and protect an entire force alone. Carrier operations make this coordination demanding. Aircraft launch and recover within minutes of one another, while deck crews move fuel, weapons, and equipment through spaces. Controllers must know which aircraft are airborne, how much fuel they have, and what threats they are assigned. Delayed information can send an interceptor toward the wrong altitude or leave a sector uncovered. When surveillance detects an unfamiliar aircraft approaching protected airspace, an interception begins through a series of controlled steps. The first warning often comes from ground radar, airborne radar, or a reconnaissance platform that notices an unexpected track. Radar operators watch screens for changes in heading, altitude, speed, and identification. Systems such as the Joint Surveillance Target Attack Radar System can monitor large areas and pass information to command centers, while fixed radar sites maintain continuous coverage around defended regions. Operators compare the contact with flight plans and identification codes before deciding whether fighters are needed. If the aircraft remains unidentified or appears to be approaching a sensitive area, controllers issue a scramble order. Fighter crews waiting on alert run toward their aircraft strap in, start engines, and complete essential checks while ground teams remove safety equipment. The fighters taxi quickly, receive clearance, and take off within minutes. Controllers guide them toward the contact while maintaining separation from civilian traffic and friendly aircraft. As the distance closes, the interceptors use radar and visual identification to determine the aircraft type, markings, weapons, and behavior. They normally approach from a position where they can observe without creating unnecessary danger. The intercepting pilot may attempt radio contact on standard emergency frequencies. If there is no response, the fighter can move alongside and use internationally recognized signals, including rocking its wings or directing the aircraft toward a new heading. The purpose is usually identification, communication, and escort, rather than immediate attack. Several real encounters demonstrate why spacing and professionalism matter. In January 2018, a Russian Su-27 intercepted a United States Navy EP-3E Ares, 2 over the Black Sea. The Navy reported that the fighter passed extremely close and crossed directly through the reconnaissance aircraft's flight path, creating turbulence. In December 2022, a Chinese J-11 fighter flew near a United States RC-135 over the South China Sea. According to the United States Indo-Pacific Command, the American aircraft took evasive action to avoid a collision after the fighter approached its nose at close range. Another encounter involved Russian aircraft intercepting a United States bomber over the Black Sea. Such incidents can become dangerous because wake turbulence, high closing speeds, and limited reaction time leave little margin for error. Once contact is established safely, fighters may escort the aircraft until it changes course, leaves the monitored area, or reaches a point where another unit takes responsibility. Pilots continue reporting position and behavior to controllers throughout the escort. After the mission, the fighters return to base, enter the traffic pattern, and land. NATO air policing turns this interception process into a continuous peacetime mission. Allied fighters remain on alert around the clock to identify aircraft that approach or enter NATO airspace without proper communication, flight plans, or identification. The Baltic states do not operate the fighter forces required for this task, so NATO members rotate aircraft and personnel through bases in Lithuania and Estonia. Ground controllers monitor regional radar tracks and order quick reaction aircraft into the air when a contact requires investigation. During Baltic air policing missions, fighters have intercepted Russian military aircraft traveling between mainland Russia and Kaliningrad. Many encounters remain routine. The NATO pilots approach, identify the aircraft visually, record its configuration, and escort it while maintaining safe separation. The wider picture is supported by NATO airborne warning and control system aircraft. Their large radar dome allows crews to monitor extensive airspace, track multiple contacts, and share information with command centers and fighters. From altitude, the aircraft can extend surveillance beyond the limits of ground radar and help coordinate responses across national boundaries. Air policing is defensive. Fighters are not launched simply because a foreign military aircraft exists nearby. They respond when identification, communication, routing, or behavior creates uncertainty. Controllers and pilots then work to resolve that uncertainty without unnecessary escalation. From the RC-135 collecting electronic intelligence to Hawkeyes managing carrier airspace, fighters conducting interceptions, and NATO crews guarding the Baltic, modern air defense depends on connected layers. Sensors find the contact, specialists interpret it, commanders make decisions, and pilots respond. Safe conclusions prove that restraint, readiness, and accurate information can protect airspace without turning tension into conflict. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.